familiar faces. So thanks for coming out to 3 Oakland, Tuesday, June 8th. So this is our 9th month. Outdoor spaces. Our featured presentation tonight is by John Sierra, who is his work is actually phenomenal. You guys see the tracking for his course directs. John has shown has done some lighting talks at some of the past year. Now it's allowed, especially with experience. So without further ado, privilege and honor to present John Guerra.
Thank you.
This session will be interactive, so you're encouraged to go. Follow along, and we're going to have a Google Hands.
Hopefully that will work.
Awesome.
Okay, thank you, man.
Thank you.
So, hi everybody. So the idea is that I want you all to go and visit this URL. If you are not there, please do it now. The idea is that I will be trying to do a kamikaze I'll be trying to code some things directly on GS Fiddle. So if you go all here and then first follow these initial parts and then jump straight to part 2. That's what we're going to be doing. So without further ado, let me take you there. I hope you can see that. All right. If not, please let me know if you see I'm going too fast or if you have any question, please stop me. If not, then I hope all of you know GS Fiddle. That is that you go to gsfiddle.net and then we want to use the library B3. So we select it there. Very important, you need to put this node wrap in body, okay? Apart from that, we're going to be using some libraries, but I'm going to add that in a minute. And the idea of the document is that I will be coding some stuff and I'm going to be following some steps, hopefully. And then if you guys want to, you can try to follow me. Or if you prefer, you can jump to the different steps and then just start from those checkpoints. So the cool thing about GS Fiddle, as I said last time, is that I can come here. Can you guys see there all right? And then we can write some HTML here, put some titles or something. Step 1. And then just by running this, we can get that immediately here, the results. So in this section, I want to start by loading some data. And the idea is to start visualizing some networks. So a network, it's those data sets in which you have some nodes that are connected by different links that relate them. We're going to be using a Flickr data set. So for that, I want you to go and search for Flickr API. So if you search for Flickr API, you should be able to find this link. You go to Flickr Services API. Then in there, we are going to be using a method of the public Flickr API called interestingness. Interestingness, here it is. So that method returns the list of the most interesting photos of Flickr during that day, is what we call in Flickr the Flickr Explorer. So if you go to Flickr, then you can see here in Explore, you see a list of very outstanding photos that are worth watching. So each one of those photos will have some characteristics that we are going to be retrieving using the Flickr API. If you don't have it now, still, I recommend getting the Flickr tab. That is this beautiful tool that every time I open a new Chrome tab, it loads one of those photos. So it's kind of good to stop. the documentation for what you need to pass to the interestingness get list method, and then it shows what's the format of the return object in here, and some error codes and things. But the most cool thing in here is that you can use the API Explorer, this function in here, and then we can go there and select JSON, say we don't want to sign the method, and then I'm going to add the extra tags and count views here in extras. If we do that, then here's an example of what we will get. And each one of these is a different photo. And here is all the attributes we will get. And this is the most interesting we will get is the number of views, although I think I'm not going to use that directly. And then the tags that we have for each photo. And then what I want to build is that I want to build a network of co-occurrences. So I want to see which tags appear together in the same photo. So basically, I have some code that basically will count that panorama and art appear in one photo, and then it will count how many times it appears in other photos. But the cool thing of this is that this returns an URL in here that we can copy, and that's what I want you to do. I want you to copy that URL. If you load that into a browser, then it returns a JSON file. That's what we have in here. And that URL is the one we are going to be using here. So we are going to create a variable called URL, and then we save that in there. If that was too fast, then you can just jump to the step 1, and all of that is copied there. This URL is using a temporary API key. So that if you guys were trying to follow the steps from the previous session, it shouldn't be working just because that API key expires after a couple days, I think. So this URL is just the endpoint that we can use to get a JSON object. And to load some data, we can use the d3.json method. That method returns, or actually has 2 parameters. One is the URL, and the second one is a callback function that receives 2 parameters, error and data. If there's an error loading the data, then this variable would get a value. And if not, in this object in here, we should get this thing that we have that we see in here. And actually, let me add another one in here. Let's say that we want 500 photos per page. So I'm calling that again. That updates my URL. And with that, let me jump in here. See in here. Good. You can see the parameters per page, 500 in here, that we want count views and all of that. So the good thing here is that we can now say, let me log the data. And I'm going to be really bad coder here. And I'm not going to do any error checking. I'm just hoping for the best. And then here you see the return object. That return object has a photos, that has a photo, that has a list of elements, and that list of elements has each one of the photos. Is that clear? So it's basically this same stuff in here.
What did you choose? What were the arguments?
Oh, the arguments. It's in extras, use tags and count views. And in per page, I put 500. Then you need the output to be JSON, and you do not sign the call. And then you call method. So when you do that, it generates a nice URL here. That's the one you want to copy, paste into GS Fiddle. Again, if you want, you can just jump to step 1, and then you should get that in there. Okay, good. So the next thing I want to do is that I would like to build a network out of all of these tags. So I can spend some time writing code in here, but I'm going to use the technique of the TV shows, and then I'm going to use a code that I have already pre-baked. So if you go to infovis.co/flickr_utils, That's an URL that returns a library I put there specially specifically for this talk. And then there's a function in there that creates a tag network out of that data.json that we just received. So it's infovis.com/. And then you paste the URL of the library you want to add. And then we click on OK. We get a warning saying that it's not HTTPS, and let's ignore that completely. And when we do that, we should be able to now call a method Flickr utils, I think it is. Should be able to call this Flickr utils get that network out of the data. And then let's save that in a network variable. And again, let's dump that into the console. So we dump that. Here we got the result. Oops. Let me jump this. So that function returns, it's an object that contains two elements, the nodes and the edges. And the nodes, it's basically just a list of objects. And each object is going to be one of our dots in the network. In this case, the network, each dot or each node is going to be one of the tags. So those tags, we are counting in how many photos they appear, or how many times they appear. And then we're going to use that later to show the sizes of the elements. Okay? Is that clear up to there? So to show a network, we need nodes and we need edges or links. And the nodes is just a list of objects, usually with an ID or something that you can use to identify them. In this case, it's going to be the name of the tag. And the network, the edges, there's going to be an edge between two tags if they appear in the same photo more than once. Now, actually, this function I'm calling here, you can pass another parameter that says, I want to specify what's the minimum number of times that those two tags should appear in the same photo, or actually, what's the number of photos that those two tags should appear in order to be considered for this network? Because otherwise, it's going to be a huge network, and we don't have enough visual real estate. So you can play with that value later. But then again, here's the nodes. We have 39 nodes, and we have 46 edges. And the format of the edges, each is again a list of objects, and each one of the objects contains 3 parameters. One is the source object, that it's again just the same format that in the nodes array. And then a target that again, it's an object in the format of the nodes array. Is that clear up to there? Any questions? Are you enough confused? Say that?
Okay, runtime error inside that Flickr. Yeah. On split, yeah. So it says, the object is kind of split on, it's not. So
Did you add the tags in the did you add the tags in the extras? So the question is, if you are getting an error on split,
yeah,
you have to make sure that you have these extras. So maybe the tag, so that's why it's failed. It's, if we just log here the data, you have to make sure that your photos, so if you dump your data into the console, you have to make sure that your photos contain the attribute tags. If you don't have that one, then it will fail. Again, in the Flickr API, it should look like this, with a comma. We good? Good.
on the edges, do you have the source and target also have the values? Is that also required?
The question is if in the edges you need the source and the target. That's the minimum requirement. But we are going to use the density of the edges to show some attributes. So remember, we are showing the network of tags, co-occurrences in the Flickr Explorer pages. And then we want to show two tags that appear more together than two other tags, if that makes any sense. OK, so that's step one. So we have data now. We haven't shown anything. But at least we have some data that we can play with. OK? So now for step two, we can start like drawing some stuff. So the first thing is that now we have a div in here with the chart. The typical thing we do in D3 is that let's create a bar width, let's say for, I hope 800 is good enough in there, and a height of 600 maybe. And then I'm going to do D3 select, and I'm going to select that div that we have in here. So since we have it identified with an ID of chart, then we can do it with hashtag chart. And that will return a selection of this div. So inside that, the typical thing you do is that we are going to append to say that the width is going to be W and the height is going to be H. And let me just dump this in here just to make sure that everything is running all right. Here we go. So we have an SVG in there. OK? Now, we need to start drawing some stuff. So, and we are going to be using the force layout. So let's create that variable. We're going to call it force. And the way you access that, it's inside the layout model, and it's just creating an object of the type force. That object receives a bunch of parameters. But in this case, actually, we are going to be restarting that in a minute. And then the same thing we learned last time. Let's create an update function that receives here the data. Actually, in this case, the nodes and the links, that is what we need to draw. And this is going to be the one that is going to be doing all the heavy lifting. Now, in order to avoid me making all mistakes here, I'm going to be reusing one of my Bostock's examples. So if you see in the document, where is it? Here. This one. We're going to be reusing this example that shows patent suites in technology, I think. So if you go to there, and let's look at the source, I'm going to start copying some stuff. So the first thing I'm going to copy is just the CSS. So I can copy all of that here, paste it here. I'm going to add a new, well, let's leave it like that. And then when it fails, we can see it, change it later. Where is it? Did I leave it? Here, maybe? There we go. So into the update function. So the force is going to receive many parameters. And then let me start with all of this. And then what I'm going to do is, we don't need this here anymore, sorry. And then after getting the network, I'm just going to call update to nodes, comma, links. Oh, sorry. This is in network, comma, nodes, and network, comma, links. Edges. Okay. What I'm doing here is that I'm just calling my update function with the nodes and the edges. That function is the one we are seeing here. It receives nodes and links in here and is passing that to the node, to the D3 force layout. We are going to be working with all of these elements in a second, and I'm going to be explaining them across the tutorial so they can be understandable. And the first thing we need to do after having this in here is to start drawing the nodes. So again, I'm going to be copying some code from here. The part I want, we already created the SVG. I'm not going to create this rect because I don't think it's necessary. This is just for arrows. So I'm going to be copying the part that draws the circles, this one. And again, back to my GS Fiddle. This basically creates a circle selection. It selects the SVG and appends a G for and circles for, and then passes the data for all the force nodes. So notice that we are using the method that I already, the variable that I already created here out of the D3 layout force callback, and then I'm passing that as the data. Then it adds a circle that it's of size 8. And if I run this now, it doesn't show, I'm getting an error. Let's see, what's it? Where is it? Yeah, we're missing that. So let me add that tick function. Or actually, let me do it like this. There we go. So if I do that, please notice that all my nodes appear here in the 0.00. So the reason for that is that the way the force layout works is that you first initialize things like in the normal D3 way, but the force layout, it's something that gets called continuously. So the way it works is that it has like a ticking method that gets called over and over and over again every time the browser is ready. And it updates some things. So it's the one that is going to be moving our nodes. So that's the function tick that we have in here. So what this is saying is creating like a how you call that, a callback or a event handler for the tick method. And it's calling this method called tick. So if I create here a function, I need to create a function here called tick. This is going to receive the event, and we are going to use that later in the tutorial. And then if I just dump this into, every time I get a tick into the console, I should get a bunch of dots in the console, hopefully. Tick is not defined yet. Function. What might be failing? There we go. So it's creating, you see, like 200 dots already. So let's better not put that in there. And the other thing I'm going to do here is that I need to make sure that my circles appear in the right position. So let's go back again to copy some code. And here's the tick method. And I'm going to copy this part. Basically, this, what it does is that it selects all this, it gets the selection of the circles, and then it uses the transform and translate to move each one of the circles to the position dx and dy. And if I run this again, now we have some nodes moving on the screen. Is that clear for everybody? Let me copy. It seems I didn't copy the CSS, or I copied it in the wrong place. There we go. So let me pause in there for a second and actually comment this one. There we go. And put this a little bit smaller. Now we have some nodes. So let me go over that again, just to recap. So what I did is that I have my data here in D3 JSON in the callback. I'm creating my network that has some edges and nodes. I'm passing those edges and nodes to the update function. And in there, I'm creating a forced variable that is actually defined in the outside, that is just calling the D3 layout force. In this moment, I'm only passing the nodes. I'm not passing yet the links. and I'm passing some attributes like what's the size of the layout, and then some other things like the link distance and the charge that we are going to see in a second. Also, we are using an event handler of the method thick. That is actually a method that gets called over and over and over again to make the animation in the force layout. Let me make this a little bit smaller so you can see it better. Then what we did is that we created a D3 selection with the force nodes. That is basically the same nodes I had, but with some additions. And then I'm drawing circles for each one of those nodes with a radius of 8. And finally, inside the tick method, I'm calling the circle attribute transform. So each one of these nodes is getting transformed and translated to the dx and dy position. X and Y are attributes that are modified by the D3 layout, by the force layout itself. And every time the tick updates, they get updated. So that's why the nodes now can be moved. Now, the other thing is that I can drag a node. And the reason for that is because we are using a nice and handy method called force.drag that we can pass to the nodes. And what it does is that if I drag a node with the mouse, I can get it to move. Is everybody with me in there? Any questions? Always remember you can jump into step 2 in the document because I'm always right. So, any questions? Confused enough? Very good. Okay. I will have to start asking questions myself. So John, why do you run so much? I don't know, something like Forrest will do. Anyways, so the thing is that now we have some circles, but let me add some text too. So let me copy these two so I don't make any mistakes there. Basically what this is doing is exactly the same thing, but for text. And in that nice example, Mike Bostock was drawing text twice, one with a shadow on the background, with a white shadow, so it can be more readable. And then if I do it like this and don't put anything in the tick method, again, we have all the text here in the position 0, 0. So we need to include an update of those texts into the tick function too. So if we go to that code, this is the part we need to copy. And what it's doing is doing exactly the same thing that with the circle. It's just doing a transform and translate to the position dx and dy. Each one of these is one of the nodes. So if I do it now we have text. And I think that's step 3. Yeah, labels. That was an easy one. So quick recap. We are in the update function. We are creating a force layout here with some parameters. We are not passing the links yet. I'm creating some circles out of the force nodes, and I'm also creating some text out of the force nodes too. In the force nodes, in the text, sorry, I'm just adding the text function to be dname. And remember that when we were looking at the objects for the nodes, oh, where are they? Here. Remember that when we're looking at the nodes, there we have a name in there, and that's the one we're using for the text. The other parameters are just like a small dx, or like we're moving the text a little bit to the right and a little bit to the in the x and y position. And then I need to add these update functions in the tick method such that every time the tick gets called, the nodes get updated. Okay? Good. So what goes next? The links. So we are only seeing nodes in here. Let's add some links. So again, let me copy from this example. And that's the beauty of D3 nowadays, is that you can many times just adapt examples. So I'm going to copy this part that does the path. I will put that before the circles so they get in the background and they don't get on top of the nodes. We don't need this marker end part because we don't have types yet. And the class, since again we don't have types in our objects, is going to be only link. And then the next part is that we also need to update the path in the tick method. Now, the tick, the paths or the edges or the links, whatever you want to call them, in this example, Bostock was getting a little fancy. So he, instead of drawing a straight line, he wanted to draw an arc. So that's why he's pre-computing these 2 and 3 values, and then he's just drawing that in here with an arc. So he starts in position source.x, source.y, ends in position d target x, d target y, and then goes in the middle to dr, that is just this computation that basically creates the arc. So if I draw that, I think this is step 4, and I uncomment this. Now we have an arc. So if I bring this back to, I don't know, 300, there we go. So what this is showing is that nature appears, like the tag nature appears in photos that also include trees and that include the tag light and sun. It's kind of one of the most widely connected. There's a nice click in here that says macro, mostly white, and macro Mondays, explore, explored, and things like that. Usually, photographers in Flickr, when they get explored, means that their photo was featured in Explore, which is a big thing because millions of users get to see their work, okay? So now we are seeing that data, and by the way, this is data gotten, how you say that, directly from Flickr Live. So this is kind of real data. So we have Nikon in here, and Canon has to be somewhere there for the typical fight of photographers. And actually, don't see Nikon, Canon. Anyways, so but the good thing is that we are drawing now nodes and links. So
on the text that you draw the text twice. I asked why.
The reason, that's a great question. The question is, why are we drawing the text twice? And then Mike Bostock himself is answering the question here. He just is getting fancy. If you see this green over the node, it has like a white background around it. So if we remove that, basically what it's doing is I have to comment that all over the Basically, it will be just the text and then not the nice effect. So it's just a simple, fancy thing to get that. Say that again? Sure. So the path, the paths are is the code that is drawing our lines. So the path, it's basically the same thing that for circles, but circles we're using the force.nodes. In the path, we are using force.links. So after you create the force method, the force layout, and you pass the nodes and the links, remember that I had this commented before, then D3 is going to go through your variables, these two, and is going to add extra stuff. So into the extra stuff is going to get the links and the nodes with extra parameters like the X and Y position of where each edge and each node should be. What I'm doing there is that I'm just selecting all the paths. I'm passing the links as the data. And then I'm adding a path for each one of those links. And I'm saying that the class for that path is link. Okay? Then, in order to make the paths move, we need to have another update method in the tick. And that method, it's just a fancy way of drawing an arc that starts in source X, source Y, then goes to this DR that is basically this computation in here, and ends in target X, target Y, okay? So this is typical SVG path, how to say, language or format. It's saying move to this position, draw an arc with this, I think with this radius in X and in Y, I think. That's why it's passed twice. And then I'm guessing this is like the center of the arc, and then it's drawing another to this element. So I'm not an expert in that, but basically this is just drawing that arc. If you just wanted a straight line, then you just could have passed a simple move to this position and then draw a line to the other one, and that will do the trick. Is that clear up to there? Any questions? Confused enough? See that works. So, okay. We good?
So this part right here, this that you highlighted,
Yes.
is that just an aesthetic way of making it look curved, or is that something that is used widely?
Oh, you asked like using the arc instead of just a straight line?
Yeah, like I just use some like I need to keep it apart because I have constrained spaces.
Okay, so the question is if using this arc is something that it's like required or recommended. The reason why Mike was doing that here is that this was a directed network. So if he doesn't have these arcs, then there's no way he could say that Kodak points to RIM and RIM points to Kodak, because both directions will overlap. So the arc was just his way of solving that problem. And I also think it looks cool. However, I just got a paper rejected on networks, and my reviewers say that using arcs is the worst thing you could do, that you should rather kill your models.
Because I have been working on this project and I showed someone that and it had arcs in my graph, and of course it's in finance, so they're like, well, why isn't it a straight line?
Yeah, it always depends on the field, I would say. It seems that there's some evidence that using arcs in networks is not a good idea. I'm not sure about that yet. I have to, again, look more closer at my reviewers. But in this case, the reason for doing that is just to solve that directionality. We don't needed that, but since we are just piggybacking on Mike, that's why we're saying that. So our network is not directed, it's an undirected network. It doesn't really matter if June is pointing to 2015 or 2015 is pointing to June. So in our case, it could be straight line. And all of those M and all of that is just SVG jargon for drawing paths. So you can look at the look in internet at the specification of the SVG paths and understand better from my explanation. Any other question? So up to now, since we don't have any other questions, what's the next step? Scales, good. So up to now, we have been drawing these things, but we do know how many times each tag appears with another one. So, and we also have more information about how many times that tag appears in how many photos. And that comes into my values attribute of each one of those. So in my nodes, I have, and by the way, look at all the elements that D3 puts into your data after you pass that into Force. But this is my original attribute, the name bridge, that's what I'm using. But now I want to use this value to make the radius bigger when the value is bigger. So we learned that also in our previous session. The way we do that is with scales. So let me create a radius scale. And then basically it's just a D3 scale dot, and I'm going to make it linear. The range for that is going to go from, say, 2 points to 15, maybe more later. And then we need to pass a range and a domain. But I'm not going to pass the domain because I'm going to be updating that every time I call to update, to the update function. So the arc scale domain is going to be, and I have to pass in here what's the minimum and the maximum value of the attribute I'm going to be using. But D3 has a handy method called D3 extend that I can pass. And I'm going to say use the nodes. And the accessor function is just return d.value. So from our last session, you should remember this. But basically what this is doing is creating a function that goes from this domain that is going to be in the range of whatever values my nodes have into this range. So it doesn't matter if the value goes from 3 to 3000, it would always go to this range. So that's why these scales become useful. And then I'm going to change this 8 in here, and I'm going to change it for a function that receives a parameter d and just returns my scale of the value. So by doing that, I'm converting this d value from the domain of the business logic, or in this case, the number of photos, into the domain or into the range of the screen that is between 5 and 15. So if I do that now, and this should be step 5. So now we have big nodes for the tags that appear the most. So now we see that nature and landscape appear a lot. Oh, here was my Canon. Canon here, Nikon for the typical discussion. And now we want to see, and we want to do that also for the edges. Is that clear what I did there? Any questions?
You basically tell certain nodes from bigger based on the value.
Yes. So basically that node has a big value, dot value, so that's why it's bigger. And how big it's gets controlled by this. So if I actually put something like 150 here, I'm going to have huge nodes for those ones. Or like, I'm going to show you in a minute another neat trick with scales. So we can do that between, scales can work between numbers to numbers, but as we saw last time, we can also use it between numbers and colors. So I'm going to have a color scale, and this is going to be a color, edge color scale. Edge color scale. And again, it's going to be a scale that is going to be linear. I'm going to set the domain in a minute. And the range is going to go from gray to red. It's not the most beautiful scale, but I will have red things to be like the ones with the biggest values. And I'm going to also put the domain in here, edge call scale. I'm going to update it inside the update function. But in this time, I'm going to use the links instead of the nodes, because this scale is going to work with the edges. So, but passing exactly the same accessor, because it's still accessing the value. And then here in my paths, I'm going to add another attribute, another method that change the style stroke. And the stroke changed the color of that line. Again, I pass an accessor that returns edge call scale of the value. And that D is going to be my edge. So if I pass that like this, and I run it, then we have red nodes like these. 2 tags appear a lot. Same for nature and landscape, okay? And actually, we can see that reflected. Like if, for instance, I say only show me networks that have more than 20 co-occurrences, here are the only ones that survive. If I change that to a smaller number, and I get many more nodes, then I get a hairball like this, but I still can see some red connections in there. So let me put, again, this in 10. It has to appear more than 10 times. And now we have a network with colors for the edges and sizes for the nodes. Is there any question? Oh, the screen, you cannot see much that way, but anyways. Wonder if blue will work better there. No.
Make the gray yellow.
Just changing the path.
It's changing the path.
You didn't want to change the.
No, the color is for the edges because it's changing the path because it's saying how many times those 2 tags appear together. So this horrible blue in here, it's saying that mostly white and Macro Mondays appear in many photos together, way more than this one and this one. You see?
Okay.
Like these 2.
But could you adjust the thickness instead of the color?
we could do that too. So let's do it that way then. So the way we do that is that instead of having that, we will have, say, from 1 to 3. And then I'm going to change, I think it's stroke width. Stroke width. And this needs px here. Did it work?
Yeah.
Kind of. And it's easier to see in there. Let's put a little bigger. There you go. So you can decide that. Another neat way of doing that is using opacity. So you can say that links that are not that tightly connected are not that dark. So, and all of that you can do it with the edges. Is that clear? Any questions? Are we good?
Why did you change the stroke width?
Oh, just because we didn't like those colors.
I was saying, how did you do it?
Oh, how did I do it? So the first part is that I changed the scale. Remember that before the scale was going from gray to red here. Now the scale is going from 1 to 5. And then this should be, I don't know, like width now. Then the other change I made is that here in the path, I was changing before the stroke. It was like this before, and now I'm changing the stroke width. And I need to add px. It's a stupid error that always happens to me. And after 2 hours, you realize that you have to add that in there. And I added another bug. So, oh, here, this one. Here we go. Any other question?
Is there a way to launch this lower right-hand window with a different tab so that you can see your visualizations?
Oh, this is just for the sake of this demo. The answer to your question, if there's a way of launching this in a separate window, I don't know the answer to that.
Okay, I guess you got your local environment.
You can do it
Exactly. In your own environment, you will just, but I like this just because you guys can see the code and the result immediately.
Say I've used this before, you can share, and then copy it, go to the right corner.
This one?
Share. I think it's the first link or the second one. So copy that, open it to a new tab, and share.
Let me update this. Share. Oh, it's not working. Anyways, that's the idea, as we will say in Spanish. But yeah, so in your own environment, you will do it in a different way. So now, is there any other question? This is the basics for creating networks. So, questions?
So you first created the nodes and then use the links to drop between the nodes,
Yes.
and then the data has to be in that format that you have.
Yes. So a quick, like going back again through all of the elements, you need to have nodes and edges. This has to be a list of objects containing, in this case, name and values, so we can use it for the size. This has to be a list of objects having a source and a target. And each one of those source and target has to be a pointer to your node. Basically just a copy of that node. Or another way I think D3 receives it is that the index in which that node appears in the nodes array. Does that make sense? Then you have to call the D3 force layout. You pass the nodes and the links. Remember, if I comment this, then I get a nice effect that we're going to be using in a second. Like all my nodes just appear in there. You have to pass the nodes and the links, and then I have functions to draw my links. I have functions to draw my nodes. I'm adding labels, so I have functions to add these labels. And very important, there's a tick method that is the event handler of the tick event. And this method gets called all the time. So it's going to be doing all the updates of the path, in this case here, sorry, here, the nodes and the text. So this gets called all the time. And that's why we have an animation in there, okay? The way this works, and you can go and search for D3 force layout and read a little bit more of the documentation in the official documentation. They explain, Mike explains here very clearly or very extensively all the details of that. It's quite complicated to understand, but those are the basic. It's using quad trees and some optimizations. And the nice thing about the force layout is that it's a constrained system, and we are going to make use of that fact in a minute. But right now, I want to make sure that we are all in the same page, that everything here it's clear for everybody.
The only difference is typically you draw the node and the path. Here it seems like you draw the path and the node, and it doesn't matter.
What do you mean?
Like on the code,
Yes.
you draw the path first, and then the node circles.
Yes.
These two are not linked to each other.
No. So for the HTML, like for instance, that's a great question. Let me just comment this. What happens if I comment this? What will happen? Any guesses? The nodes won't move, but the edges do. So they are completely independent elements. Okay? So yeah, that's a great question. So for the browser, it's just drawing that over and over again. So if I don't have that, the nodes are all in here in the 0, 0. And that's why you see a bunch of lines moving around. Okay? Any other question? Can we go into the fun stuff? Okay, so we have some scales, and here we can play with some parameters. So I don't know if you noticed, but I added some elements in here, like the gravity. And the best way to understand that, Mike has a great, and I think I put that also in the document. Here, go visit this link. This is a talk that Mike gave explaining the force layout. It's explaining many of these elements. You can start moving with the arrows. But I want you to look specifically at these slides. So these explain the main concepts that are used in the force layout. So you can have concepts like this, that is repulsion between nodes. So look that every time I move my mouse, it is dropping new nodes, and those nodes are trying to repel each other, okay? But you can have the opposite, that is that the nodes attract themselves as if they were gravity, okay? So if we look at our example, that it's being controlled by the charge. So this is a negative charge, which means that the nodes repel themselves. So if let me comment this, and let me add a big repulsion, like 1,000. If I do that way, the nodes are very separate. But if I put a smaller value, like 10, then everything gets smashed together. The reason for that is that there are some extra forces, and the nodes are trying to repel themselves. That's why this is a negative value, because they are repelling. If you want them to attract themselves, then you put a positive value. There might be a reason for you to do that, but usually in the network visualizations, you need a negative value. And in this case, the sweet spot for this small screen is around 300. You might need to change that depending on your data. So depending on the type of network, this is a nice sparse network, so this value is good enough for that. So that's the charge. Again, we have repulsion or attraction, and the bigger this value, the more repulsion you have between the nodes. Is that clear?
One question. The
Well,
distance between those groups, do they mean anything, or
which groups?
like we have these groups of on the far right, explore and explore. It's not connected to anything else.
No, it's just the way this works is that we have a bunch of forces working in this layout. And the nice thing about the D3 layout, the force layout, is that it's just a collection of constraints. So there's a constraint that tries to put the nodes apart, and that's controlled by this charge function. So the whole network starts in a chaotic state, you could call it that way, and then it starts like applying the forces with some alphas to try to damper that change until it reaches a point of stability. That is the moment in which everything stops in here. After that happens, the tick function is not called anymore, so you are not wasting resources in there. And it will, the system will get again in stress if something like moving a node happens. So in this case, this distance doesn't mean anything. But what you're asking is a great question, because I'm going to start using the X and the Y position for some things in a minute. But I want you to first start playing with the parameters, things like the charge, or we can look at, where is the presentation? Here. So we have mutual attraction, and we have mutual repulsion. Something else that we can have is gravity. And this is something interesting that you will find in D3, in the force layout of D3 that you don't see in other network systems. And is that you have like a sinkhole that you can place wherever you want in the screen. Usually that sinkhole is in the middle, and that thing is attracting everything to the middle. So that's being controlled by gravity. So I can change that, and I can put values here like gravity of 0. If I put that, then there's no attraction to the middle, and then what will happen is that the nodes, they can go and fly away from the screen, and then you won't be able even to see them, okay? But if you put a value like 0.9, I think the values of gravity goes from 0 to 1. If you put a value of 0.9, there's a lot of force keeping all the nodes in the middle, okay? So you need to play with all of those. I think the regular value they have normally is 0.1, and that's what we have originally. And then values like 0.05 or things like that, or 0.01, is kind of nice because it leaves the network to move a little bit, but you still get some attraction to the center, like things like this. So we have two attributes, the charge and the gravity. The charge controls how the nodes interact between themselves, and the gravity controls like a massive sinkhole in the middle, okay? Next one, questions in there? Why do I get so lost? Here, gravity. You can have gravity plus repulsion. So these, all the nodes are being thrown into the middle, but the nodes also repel themselves. So that's why they don't smash together. Then you can have link constraints. And the link constraint is what tries to put the nodes together into the same element. So if we do that, this is being controlled by the link strength. And then I think it's again a value that goes from 0.1, from 0 to 1. Let me put gravity 1 in 1, back in 1. So if I do it that way, the links are a little bit loose. But if I put a value like 0.9, the links are going to be very stiff. So they're going to be trying to stay in the 80 value that I gave in here. So if I put a value of 10 in here, they will try to stay really small, even if there's forces trying to separate the nodes. So this is a lot of parameters that you can play with. In this case, this 80 is the one that is keeping them apart. And for instance, if I put a value of 0.1 and a link distance of 10, even though I recommended the links to be really close, they're still separating themselves just because there's also repulsion between the nodes. So the idea is that you can go and play with those parameters yourself. I recommend watching, there's a video also explaining all of these elements. But those, like setting those magic, will make your network look better. Is there any question? Any other question there?
So the link distance is the distance in pixels, how far apart they should be.
They should be. So the link distance is the distance in pixels of how far apart the the edge should be. So if you put a link strength of 1, there will always be that value that you put in there, no matter what. So if you put a value of 0.1 or something like that, they will try to be that, but if there's a force stronger than that, they will relax to something. So it depends how important that is to you. So if you want to encode something like 2 nodes together means a strong connection, you should have a link strength, a big link strength, because you want to guarantee that. But then you also need to play with other parameters, like do you want to overlap nodes? And I think that's the next thing that we're going to do now. Okay, so this is a little playful area. So I created a bunch of libraries that lets you do network clustering and what I'm doing here. Network clustering into directly on the browser. So if you have a network like this, so if you go and visit that link, there is saying that you can use this network clustering just with 1 line of code, and then what you get is that you can cluster the nodes according to their connections. So let's use that in our network. So we will just need to add this resource, again, to the GS Fiddle. Here in the external resources, I'm going to paste that. And then, no, that's not that one, not that one. Where am I? Nope, here. And then I just need to add this line, net clustering, network clustering. I'm going to do that before calling the update. So this goes with network here and network here. If I do that, what will happen, and actually let me print this after the clustering. What this will do is that it will add a new parameter into my nodes that is going to be called clusters. And that cluster is a compute element that we can use to differentiate the nodes. So to show that, I'm going to create yet another scale. And I guess the Warriors are doing well.
The latest is that they're losing.
Oh, shoot. OK, they're losing. D3 is scale. And I'm going to use the all-beloved category 20 scale. This is a color scale. And I'm going to use that here to paint my circles. So I'm going to put a style and change the fill, the typical function, D. And I'm just going to return, how did I call it? Called scale. Scale of the cluster. There we go. And voila. So now this goes into one cluster. All of these go into a different cluster. And all of this is being pre-computed in the browser directly. And as you can see, it's quite fast. I'm just saying, so you can use that library. The way of finding that is you can check my blocks. Now I want to use another library that will separate those nodes into their own space. And this will be a good way of explaining the concept that goes next. Again, here's the code of what you need to add. And I'm going to copy that into an external resource here. This is my library. OK. And group in a box. Here. So I just need to replace the D3 layout force to D3 layout force in a box. Where is it? Here. Force in a box. And if I do that like that, then the nodes start trying to go to their own position. But then let me add a couple of parameters in here. I can now put a gravity for the force and the link strength between the clusters. So too big. wonder what else I need to add there. That part is not working well. Change this maybe. Okay, that part of the demo is not working, so let me ignore that and pass to the next one.
Can you show that previous one, net clustering, the code we have?
This part?
So you pass in the
Putting that here, and then in the circle, I added a style fill of the cluster.
okay.
So it's changing the fill color of each one of the nodes. For some reason, this one is not working. Let me try again. Group by cluster. Still need the nodes and the links. The width and the height, that's the same thing. Let me remove that. Quality to force, charge. Oh, I forgot one thing. Good thing I remember. I need to add this into the tick. So I add that into the tick method. Now it's working. So it puts each one of my clusters into their own group, and it separated that into different elements. So the difference between that and the regular force that we had is that if I replace this for the force here, the normal force, and I commented out the things that I don't need, these ones, and then this method goes away. You see the difference. This is the regular force layout. Everything is going to the center, but then it's kind of difficult for me to know what are the different clusters. So what the group in a box library does is that it creates different boxes in which it puts each one of the nodes. And I made a mistake here. Force in a box. There we go. So you see all the orange nodes are in this area. Can you see that in the screen well? Kind of. All the green ones are in this area. So it's a way of separating the nodes such that you can see them more clearly.
How does that know how many clusters to
The clustering network, it uses the, what's the name of the library? Uses this algorithm.
Okay.
And that algorithm, you don't need to tell them how many clusters it will get.
Okay.
It tries to infer that out of the data. For details, I can pass you a link to the paper that does that. So you can use that those two libraries that easily. Is there any question in there? It can be useful for some projects you may have. But then I sidetrack a little bit, so let me go back to force. And then let me remove this. Actually, let's leave the ones we have initially. Link strength, we want that. The charge was 300. The gravity was 0.1. And then let me remove this. Okay, so here's what we had before. Now I want to start playing more with the forces. So one of the things I want to do is use collision detection. So again, if you search for D3 force collision detection, Lightbox has some good examples showing what this does. What happens in this example is that all the nodes are going towards the gravity point or the massive sinkhole, but when I pass the mouse, they try to repel that, and they never overlap over the others, although that sounds redundant. So, for instance, if I put a small charge, like say of 3, they all smash together. And let me make the nodes a little bit bigger so that can be more evident. You see? So I don't want that. I want nodes to keep their own space, and I don't want collisions. So I'm going to, again, copy some code from maybe this one. Let's see, page source. Yes. What I want is this function, the collide function. Let me add that here after my update. That function basically, for each node, checks if that node is colliding with some other node. I need to update a little bit this. So my radius is going to be from the value. But in order to make that work, I need to convert that into pixels. So I need to use my R scale. R scale. And R scale here. And then the only other thing I need to do is to call this function into my thick method. So we can do that here with these 3 methods. You see, this is in the thick method. So if I go to the thick, and this is creating a quad tree of the nodes to allow to find the collisions. I don't like this way, so let me do it nodes for each. Then create a function, O for the nodes. And then what I'm going to do is use the quad tree to visit each node with the collide function. Right? I don't need these 2 anymore. So what this does, again, is just that it goes to each one of the nodes, and if there's a collision, it will try to move the nodes apart. Let's see if this works. Of course it doesn't work. Missing argument. We do need that there. Closing that. Function here closes. Oh, sorry, the other way. Here, like that. Yes. There we go. So let's remove that. Let me make the nodes a little bit bigger so we can see that more evidently. Now the nodes are not getting in top of each other. You see? And that's thanks to the collision detection. You know, I went a little bit too fast in there, but you can check more of the details of that code. What this code is doing here is just getting the radius of each one of the nodes, and using the quad function, the quad tree, is checking if they are overlapping, and if they are, then they're trying to move the nodes a little bit to the sides. Okay, but it's you can think of it as a chicken recipe or a cooking recipe of how to add it in there. Is that clear in there? Sorry, I'm rushing in there.
But was it not, was not having its own radius repel each other?
So the nodes are repelling each other. But the thing is that even with repulsion, sometimes they might get into the same position. So with collision detection, like here, we have we don't have much repulsion. So let's say we have a strong gravity that will try to bring everything to the center. The collision detection, it will avoid that to happen. So, and now, again, remember that trick? What happens if I comment this? And we don't have links anymore. Nodes try just to go to the center, but they just keep on fighting there because they will not get on top of each other. That's what we want to do. Okay? Now, if that's clear, then the next thing I want to do, and by the way, I totally forgot to update the steps. The next thing I want to do, we are in step 9, I think now, is that we have some nodes that are like bigger than the others. What if we could put the nodes that have, or like the tags that have more photos on the top of the screen, and the tags that have less photos on the bottom of the screen? So let's try to do that. So let me put this back in 1. We had this in 300. There we go. So now, in order to do that, what I'm going to do is a small trick in here in the nodes. Inside the tick function, this is iterating through my nodes, and then what I'm going to tell them is just that the position for y is going to be, say, 100. So if I do that, all the nodes will appear in the position 100. So I'm fixing a constraint in there that it's saying all the nodes are in the position 100. But I actually want them to distribute themselves on the screen depending on their value. So the way of doing that is yet another scale. So oops, let me create, in this case, a y scale. Y scale. And this one is going to go from 0 to h, the height. Same trick in here. I'm going to update that with the nodes. Oops, white scale. And then instead of putting that into 100, I'm going to call white scale of O value. If I do that, now the nodes with the higher values are on the bottom, and the ones with the smaller values are on the top. Let me put this that goes from 10 to h minus 10. But I don't want that. I want the opposite. So a nice trick with scales, and please notice this, I'm going to change the order of the scale. That goes from h to 10. Lucky, huh? So now things go to the top. So that's typical with scales. Just by doing that, the scale will know that it has to switch things on. And now this node, it's on that position, and the y position is exactly the ranking. I will say it's kind of like a scatter plot / network diagram. Is that clear what I did there?
So if where do you use the y scale is in the tick function?
I use the y scale in the tick function inside the iterator I have over the nodes. So for each node, instead of letting D3 handle the position, I'm overriding that, and I'm putting exactly my own value. Okay?
This is independent of the collision detection you have, right? So you don't need.
I'm doing that before the collision detection.
Okay.
That's why I still have collision detection. That's why these will not move. You see? I cannot get that on top of the other. So I could say, I could try to put things all, again, doing the same trick with X, putting all of them in, I don't know, 300. But then collision detection will make them fight. If I remove the collision detection, they will get on top of each other. You see? Or if I don't have this, then all the forces will happen, but then I don't have collision detection. I do have repulsion. You see, that node is kind of moving, and is getting attracted by the others, but it's not enough to avoid the collision. And that's actually a good example of the collision detection.
Sorry. After the inclusion of the collide function, there's a lot of things happening in the collide function. It's very.
That's a complicated part. I'm not sure if I understand it myself. One way of looking at that is that it's getting two nodes. The node 1, node 2. Basically, oh, sorry. This is getting a bounding box of the node. So from the x minus r, that is this radius, and from the y minus and plus r. Then this function, if I'm not mistaken, this part is where I get lost in here. Basically, what this is doing is that it's using the quad tree to try to see what other nodes are in there and then compare that versus the other. And then if there's a collision, that's what it's doing here. But I don't understand it completely. So yeah, the question was more intuition on the collide, but I don't understand it completely.
Also learn like a quadrant, like a linear quadratic, like shape as opposed to a square shape.
Yes, like a square. It's a square. It's a bounding box. It's kind of a square.
And I believe it's doing this.
However, there might be something else there, because remember, if we disable the links, let me disable the y that we are setting, and then let's run it like that, and then let's add a big gravity. Like, notice that the boundaries are not really squares, so there might be something else happening in there.
It's also though because if there's spheres, they're never gonna be able to form a perfect split.
Yeah.
There's always going to be a void on the sides. The boundary for the whole like quadratic shape would still be there, and it just has space on both sides as well. The whole, like, sphere together.
So yeah, so in any case, the collide function is beyond the scope of this tutorial and my understanding. So, but it's still useful. So let's add back the restriction, the constraint we have for the y position. And the thing with this is that it's setting the specific value for the y position. And I don't really want that. I still want nodes to kind of go towards that, but I don't want to fix it in there. I still want the force layout to move that. So to change that, instead of putting this in here, what I'm going to do is that I'm going to compute the difference between the desired position and the current position of the node, multiply that by a k constant in here, and that k constant comes from getting e dot alpha, that is a parameter of the forced layout, and strength. In this case, I'm going to put 0.1. What this is going to do is that I'm going to change the y position to move towards the desired position with this strength, but not necessarily exactly into that position. So if I do that now, now look that I can now drag an element. It will try to go to the top, but it's not necessarily has to be in there. Okay? I removed the links, by the way. That's why they're looking like that. Let me put that like in a lower value. So this is kind of interesting, for instance. Like the orange one will try to be on the top. This Nikon, if I leave it go, it will move. So you can get nice effects like that. If I increase my force, where is it? Here in my thick, like 0.3, then they will try to go a little bit more to the top. So you can create nice effects with things like this. Like this node tries to go to the top because it's bigger, and elements like that. Again, what I did is that I created a constant that comes from a parameter called alpha out of the force layout. I'm multiplying that by a force that I define in myself. And then I'm changing the y position to try to go towards this objective. What it does is that it computes how far away it is, and then it dampers that multiplied by the constant I created. So this constant should be something between 0 and 1, I think. So this is going to be a fraction of the space I want to move, and that's why it works. Is that clear? That's a complicated thing. I just babbled there.
What you're doing is nodes that for each on every tick. Is that going to be too much?
I am doing the nodes dot for each for everything.
Because you don't control how many ticks happen, right?
No. But the nice thing about the D3 force layout is that the tick method, it's only called when the browser can do it.
Okay.
So if you have too many nodes, then you will have less ticks, and then you have less animation.
Okay.
but then it just skip it. So it tries to cope up with it. So there's some magic happening in the background trying to get you that working. Any other question? Now I have set the Y position to be the value of the node. Now I'm gonna get fancy and also create a X position. But for the X position, what I'm going to use is that I wanna position the tags across the X position depending on the first letter of the tag. So the things would start with A. That's the only thing I could come up with. The ones that start with A will go to the left, and the ones that go to Z are going to the right. So I'm going to create another scale. The domain is going to be the same here. The range, this is going to be X scale. This one can be from 10 to width minus 10. This one can be like straight. And the domain for this one, sorry, is not this. Sorry. This has a fixed domain. The domain for that is going to be from A to Z. The thing is that a linear domain has to go from a numeric domain. So what I'm going to use there, it's the old char code at, I think is that the way it is, 0. Basically, this gets me the ASCII code of A, which is smaller than the ASCII code of Z. And please notice my extreme effort to pronounce the Z because I don't have that sound in my language. And then I want to update here my X, same thing. I want X to use X scale of the name dot char code at 0. So this gets me the ASCII code of the first character of that string and the X value. And let's do it as we did the first time. Let's put it fixed first. We can know for sure if it is working. There we go. Kind of nice, isn't it? Then let's add it as it was, and let's make this stronger. So now things are to the left if they start with A, to the right if they start with Z or something in the alphabet, and to the top if they have a high value, and to the bottom if they don't have a high value. I have removed the edges. Let me add those back again. And then we can have a very Frankenstein-y network that has some meaning on the X and Y position and yet still have some forces. As you can see, you can get really fancy with this. And then you can start putting different fuzzies in different places and move some nodes towards them. That's how the group in a box works. Where is it? What the group in a box does is that it basically puts a fuzzy in here, like different sinks, and then each cluster gets into its own fuzzy. So if you look at the examples in the fourth page, in the fourth layout page, you can see more examples that do exactly that. I added back the links, and that's everything I had for today. Is there any other question? Concerns?
I think you mentioned this earlier, right? When I was talking, the arcs, is that what you define that it's using arcs instead of straight lines?
You can use straight lines. The only reason why I'm using, the question is why I'm using arcs, is that because I'm copying Mike Bostock's code for, what is it? Search it again. This one. So I was using my code that was based on this one. And in this example, he needed to have directed links. So in order to have this case, like HTC points to Apple and Apple SUS HTC and HTC SUS Apple, you need to have the arc. So you can separate them. But if you prefer having them straight, the only thing you need to change is Here, this part here. This is the part that is moving, and basically you will remove this part in here and just leave it. Actually, let's do that now because you are like the third person that asked me that.
I think
L,
yeah,
like that, like line. Capital, like that. Works. Okay. I know, but that's not what my reviewers say. So
in your force in that box,
yes,
you said you're separating, so you're creating some sort of a I guess,
sinkhole. Yes,
sinkhole.
I'm creating different. Basically, if you search for the D3 force layout, you will have this example in here, the multiple fuzzy. This one is doing basically the same thing. The way it works is that if you look at the code in here, in the tick function here, you have the iterator over the nodes, and the same code I was showing you, and this is the desired position for X1. So basically, this is just a hash table for the ID of the node. In my case, I do it for the cluster. And the way the group in a box works is that the way I compute where to put them is that I compute a tree map out of how many nodes are in each cluster. And then the centroid of that tree map is the fuzzy or the sinkhole for that cluster. So basically, this function in here is doing just that. That makes sense? Any other question? I know it's quite magical.
How do you go from this layout to exploring other layouts? You show us this, like, about tree map. Each layout.
Oh, you could use something fancier, like the one that I like a lot. Usually, it's doing a scatter plot / network, like the typical one, and that works perfectly for Twitter stuff. Like you are tweeting, you are drawing a network of users in Twitter, and you want to get people that have a lot of followers and follow a lot of people into the X and Y positions, you know what I mean? So if somebody is in the top corner, like say the Y-axis is how many people follow them. So somebody in the top corner will be somebody that is famous. Then on the X-axis, you put how many people they follow. So if this person follows a lot of people, that means that it's in the upper right corner. That means that it's one of those people that just follow you, so you get followers back. But you can identify very easily the people that are famous versus the people that follow a ton of people that nobody follows them. So, and you still see connections, like things like that. So the beauty of D3 force layout is that it's not really the typical Spring-based network layout. It's not restricted by that. It's a beauty of just a constrained, soft constrained system. And you can add as many constraints as you want. You can say links joins the nodes. Like in this case, we have a ton of constraints in here. Links joins the node. Links join the nodes. We have a gravity that joins that puts the nodes to the center. We have a y-axis that is sending nodes to certain positions, but yet we have collision detection, so nodes don't overlap and things like that. So that's the beauty of the D3 force. Please.
So I've seen some demos where they will drop a node after that, like stream, and then it goes into its place. So how do they do that? Like when you add a new node, are you redrawing everything or just adding that one node into it? Using the enter method, does it come here? How do you add a new node into this?
Let's see if I can make this work.
Maybe you can give all data except the last one and then try to run the last one again.
Now let me do this. So let me create a network outside this function. Let me call that there. And what I'm going to do is that, remember, you have to change that. So now I have my network here, okay? Now I'm going to cheat, and I'm going to add a new node. And the values for that node are going to be, I need a name. So it's going to be John. And the value for John is going to be huge. Of course, John has to be huge. Now I'm going to call again the update. And let me make this smaller so we can see it working, if it hopefully works. Here like that. Actually, it should go there. And then I'm going to call again update. And if I cross, do you see John appearing there? It appeared, but it moved to some other position. So what I'm trying to say is, the way I did it like this is that if your network changes, you just call again update, and then it will add the node in there. So there's a ton of examples in the same page, like for instance, this one. So this one lets you construct your own graph. So it's basically just calling many times the force layer. So it's actually quite simple doing that. Any other question?
So if you wanted to make like scatter plot that was more forcing,
Uh-huh.
but how would you come up with so one of my challenges with using was that I don't always understand what the links are.
Yes.
I just know what the links are.
Yeah, so pretty much, if I remove the links in here, here, links. Come on. If I remove the links, I basically get what you're asking for. This is kind of a scatter plot forcing.
So you don't actually, yeah, but you still kind of need links.
No,
Oh, you don't.
you don't.
You don't need to define any link.
No. So I can pass, so
It's been a big misunderstanding.
yeah, so you can use the force layout without links. And then it will handle the nodes, it will have the tick function. And then the secret is creating these fuzzies for the positions. So I'm trying to move my X and Y's to these positions. And that's why they're trying to get into those. So does that make sense? So the question was, how do you make a scatter plot that has more like forces in there? So yeah, basically you just, in this example, if you don't consider the links, is pretty much what we did. If you want to, again, if you want to force something to have the exact value, then you don't have this dampering. You just put it like, no, the Y has to be the right position because that matters to me. And that way you can just draw the scale and I broke something. Oh, here, this.
Isn't there a relation between
You still have that, but if you want just the scatter plot, then it depends what parts you want. Like, do you want nodes to repulse or not? Like here, you can put the charge to be really small, so it's really not playing any role in here, but I still have the collision detection, so that's separating them. Or I could say, let's add a huge charge, so the nodes will definitely try to be apart. So it depends on what you want to do. In the example that I understand that you're proposing with the scatter plot forcing, I'm guessing that it's more like using the collision detection. And
a little bit of the bouncing.
yes, a little bit of bouncing. But I'm not sure if I'm understanding your question right. Yes, but notice that no matter what I do, this nature will not get out of that Y position.
Right, but if there's other factors like you were showing that you added in.
So remember that
added in, then you could.
if I set this to be like this, let's make this a scatter plot, pretty much a scatter plot with collision detection. Then we will get a lot of fighting in here. Like if I remove the collision detection here, and I run it like that, and I broke something, come on guys, don't let me make those mistakes. That's a scatter plot. And there's no other forces in there. Like I'm completely ignoring them because there's no way of moving the nodes, you see? So it's pretty much just a scatter plot. So that's why you have so much overriding.
I'm just kind of thinking, you're adding in a third variable into,
Which one?
unless you have it, maybe.
No, the thing is that
You have like the collision, or you don't have it, you have like X and Y.
I have the X and Y. I'm fixing the X and Y's, so that's why they're not moving. And I'm completely ignoring the force layout, like the charges, the gravity. I'm ignoring all of that because I'm setting my X and Y's and putting them into a very specific position. So usually you don't want that because why would you do a scatter plot like this?
Right.
Usually you want more like, no, I want a kind of like a scatter plot, but I want to be flexible with the Y. So that's why we add this dampering. Oops, I did it here. So for instance, my Y is going to be fixed. There's no going to be change there, but the X I can change. So in that case, and again, I broke something. Unexpected token here. There we go. So now, and the charge was too big, so let me lower this. So now you have extra forces in there. The Y position is guaranteed to be in the Y because I'm setting that straight to the value you want, and I have extra values. I have the collision detection, but the Y, it's perfect. It's exactly what I wanted. So I guess that's what Samin wanted. That it's like it's at least one variable that it's like fixed, and like one way that it's typical to use this is that, and you see a lot of New York Times visualizations of this. It's like let's put things in the middle, or actually Y divided 2. There we go. So you kind of put everything in the middle. I have collision detection. And the Y position, it's, and let me reduce this. So things just get into the middle. So it's, or you can do it the other way. Like usually you do see that in the horizon, and then things to the left or to the right depend on time or things like that. That's typical in the New York Times examples. Is that clear there? We still have a...
Still a little hesitant.
Okay,
But it's okay.
we can take a call offline.
Just to clarify.
Sure.
Audience, but the axis, the Y is number of photos, right?
Then yes, I think.
And the size is also number of photos.
Yes.
And then the difference, and then they're just, yeah, okay, so that's all.
And it was color coded using the clustering library. Anything else? No? Last chance? Well, thank you very much.
So thank you for this. So for those of you who are new here, which is just about everybody, this is